For the hour. I'm Danielle Gagne, and I'm the editorial analyst for Commercial UAV News. Before we get started with today's webinar, Autonomous Drone Inspection and Mapping with Skydio 3D Scan, we do have a few housekeeping notes to go over. If you have any technical questions or issues using the webinar platform, please use the chat box and we will respond right away. If you have any issues with audio, please click on the phone icon above the chat window to receive the teleconference info. For those that do call in, to ensure call quality, everyone's lines have been muted today. However, we do want this webinar to be as interactive as possible, so we have technical experts from Skydio on standby to answer any of your questions, so feel free to engage throughout the presentation. You can do so by typing your questions into the Q&A box and selecting all panelists when submitting your question. At the end of the presentation, we will have our presenters answer questions. If we are not able to answer all the questions, we will be responding after the webinar via email. If you happen to get disconnected, you can log on again using the instructions provided in your webinar confirmation email. If you continue to experience difficulty, please email info@expouav.com and we will respond right away. This webinar will be recorded and you will receive a thank you email with the on-demand materials within 3 business days. Now that is done, I'll hand it over to the Skydio team. Welcome.
Thanks, Danielle. Fantastic job to you and Laura and the whole DIFCOM team putting together another really great webinar. We're excited to be on with you, and I should congratulate you again on Commercial UAV Expo and what a great success that conference was. I think the entire industry really needed it and really enjoyed it.
Well, thank you.
And to everybody who's here, as a participant, thank you so much for being here. I see some of the usual crew here in the channel and also a lot of new friends. So we're going to be trying to make this a webinar for everybody today. Mark and I are really excited to spend some time with you this morning. Mark Flam is a program manager at Skydio. Mark, why don't you tell us a little bit about yourself and get everyone excited that they get to talk to you for an hour today. Maybe take yourself off mute first.
Hey, sorry about that. Can you hear me now?
Yes, sir.
Hey, sorry about that. Good morning, everyone. Mark Flam, Enterprise Program Manager here at Skydio. Really happy to be here. Thanks for having me. You know, I have the privilege of working with some of our largest customers to ensure that they're successful with Skydio drones. I get to go out into the field, talk with customers, understand how they're using the product. Really a phenomenal job that I enjoy doing, and I'm honored to be part of the Skydio team.
Great. Well, if you are an existing Skydio customer and you're back, the odds are very good that Mark has solved a problem for you before. So I'm excited to have him here because he gets out in the field even more than I get to these days. I'm on the marketing team. That means that I get to come and spend time with you speaking on these webinars. I also think that I have the coolest job at Skydio. Sorry, Mark, because all I do is talk to customers, figure out what's working, and tell new customers how to make it work for them too. So very excited to be here doing exactly that with you today. We're going to be talking about a quick company overview for those of you who may not have heard of Skydio before. We're going to talk about the 3D scan product and what customers are already starting to be able to get done with that. And then we're going to just talk about some real world applications where we have been out flying and we've gotten to enjoy the product and see our customers enjoying the product. And we'll talk about some of the results that they've got. But let's quickly talk first about what this company, Skydio, is, whose webinar you're sitting in. We are the largest US drone manufacturer, and we're recognized by Forrester as the world leader in AI-driven autonomous flight technology. We like to serve all different kinds of drone customers across the industry. That includes consumers, first responders, enterprise, the DoD. And we were recently the first US drone maker to be valued over $1 billion. And that's important in a world, in an industry that's dominated by these massive Chinese conglomerates. Having an American company that can grow to that scale and have the staying power to support large fleets like you see on the right, BNSF, Eagle View, the Civil Air Patrol, but also support a wide range of different fleets, over 420 customers, 15,000 units shipped, with a big piece of capital, means that there's an American partner that's available to those agencies and those businesses that really need one to stay compliant. And we're all here for the same reason that you're here, right? Which is that we see drones having the potential of this massive positive impact, but the industry being held back because the economics of the manual drones out there don't scale. They're hard to fly, they're easy to crash, and as a result, it takes a lot of training and a lot of operators to be able to operate these drones. Often you'll see crews of 2, 3, 4 pilots just to fly one drone. And you don't have to think very hard to realize that the expensive part of a manual drone program is actually not the equipment. It's the people that you have to staff or the time that you have to take out of your existing people's jobs to let them go fly these drones and learn how to fly these drones. And so what we have offered is is a solution to some problems that a lot of folks are already seeing, right? And if you dig a little bit deeper into some of these situations, you're kind of caught between a rock and a hard place, right? Where either you're dealing with really dangerous methods that don't use drones, right? Where you've got people climbing up on top of your infrastructure, extremely dangerous, or you're using really expensive methods like scaffolding, helicopters, scissor lifts, or maybe you're all the way going into buying your own helicopters, and that's going to get really expensive. Now, a lot of folks rightly have been trying to make it work with manual drones, but then there are still a few things. Number one, you haven't solved your cost problem. You need those specialist pilots to be able to get to scale with your program. Number two, manual drones today fly with GPS units and with compasses, and those don't work in a lot of industrial environments. They don't work under bridges, they don't work inside transmission towers, and they don't work near powered or heavy communications assets or metallic environments, right? And so anybody who's flown a manual drone recognizes what we call the magnetometer dance, right? Is what that pilot's doing there with their Phantom. And then, of course, you're always afraid of having a crash and the safety risks in a lot of industries where safety is paramount, right? We are so careful that we keep our people safe when we go to these job sites. We tell them about slipping hazards and tripping risk and fall risk and places they can bump their head. And yet we send them out into the field with these manual drones that crash and fly away and are really hard to fly safely. And so what is really required here is a world of autonomy where you've got computer vision, you're using deep learning on board, and what that does is let you automate entire workflows. The real standard for an autonomous drone is that it can see the world, understand the world, and act on the world. And what a Skydio drone does is exactly those three things. It carries 6 cameras that are just for navigation, that work indoors and outdoors, so that it's not dependent on that GPS and magnetometer. It understands the world with over a dozen deep learning algorithms that are all running at the same time on that aircraft so that it's building a real-time map of the environment, recognizing subjects, inferring shapes from what it sees. It can use context to understand, well, this is a blank wall. I don't see the edge. It probably continues. Let me not fly into it. And then it predicts the motion of its surroundings into the future, not only its surroundings, but its own movement through those surroundings. And that's why when it acts, it can avoid obstacles autonomously. It can automate these complex workflows like you're going to see not just in subject tracking and cinematic effects, like much of the consumer market knows us for, but also in data capture, like Mark's going to talk about later today. Um, and so people love flying Skydios. When you equip your pilots with these, they enjoy the fact that they're up in the air faster. They're not doing that calibration dance. That these drones are easier to fly, harder to crash. They can fly them into other environments where we call that Skydio airspace. Only a drone with a vision-based system can fly. It lets you fly up close so that the data that you get is better. And eventually, it lets you automate entire workflows that normally are done by humans, but just take that robotic computer precision. And the bottom line is look, there's manual drones and there's autonomous drones, and you can't think about them the same way. You got to think about them like flip phones and smartphones, right? The manual drone providers, every year they're going to come out with another drone that's a little more expensive and has a little bit nicer camera on it. And that's great, but they all continue to fly the same way. If you think about the flights that these drones can do, that hasn't changed much in the last 10 years. And yet, autonomous drones can fly completely different patterns and access areas that are completely different. And just like how you're not going to trade your iPhone in for a Motorola Razr because they added a little bit nicer camera or or a little bit more battery life, you're not going to go trade your autonomous drone for a manual drone just because they add a few megapixels to the camera, right? What's holding the industry back is not that these drones don't zoom in far enough, is that they don't fly properly. Um, so our solutions to this um, are a full stack enterprise software suite. And as I go through this, just a quick reminder that we've got folks in the chat and in the Q&A. So as questions arise on this, feel free to get in there. You've got the world's expert, Mauricio Barra, in there, who runs our product marketing team at Skydio, who can answer questions about any of these products. Because what we are offering is the full range of solutions that goes from the hardware, the controllers, the aircraft, to the core autonomy functions that live on board the aircraft, to advanced AI skills that you can add on top, right? Whether it's Skydio autonomy to make you a better pilot while you're flying the plane or the bird, or 3D scan and house scan that lets you turn over control to the autonomous system on board. And then the cloud services that help you take all of that data off of your aircraft into the cloud, integrate with partner solutions if you need to, but make sure that you run your entire drone program with accountability. And what being able to get all of this from one vendor does is free you up from having to deal with 45 different calls a month just trying to fix everything, and let you deal with one partner with full accountability, with somebody like Mark Flam, who's going to come and solve problems for you all across your fleet. It all starts, of course, with the drones. The drones Skydio 2, your autonomous drone that helps you build out your unmanned flight operations with ease. This is your starter drone. Gets you going with the program, lets you test and understand what autonomy can do, lets you equip your first few pilots. And then once you're ready to really start cranking and generate better data, fly longer flights, fly in windier, tougher environments, wider range of temperatures, maybe you're starting to use thermal. Then you've got the Skydio X2, which is your enterprise workhorse that lets you scale your operation in the most demanding environments. So what I like to tell customers is, if you're flying the Skydio 2, that's great. We're glad you're excited about it. It's a great way to prove out your program, and we'll talk about a few programs that have gotten started just with this Skydio 2. Because what it did when it came out at the end of 2019 was give any pilot the opportunity to fly like an expert, right? It's got that Skydio autonomy on it. It's got 360-degree obstacle avoidance. It's running those 9 onboard deep neural networks. That lets it fly in GPS-denied areas fully autonomously. And it's just unprecedented ease of use, right? So if your pilots can fly a manual drone, they can fly a Skydio. If they can't fly a manual drone, as long as they can use the cell phone camera on their iPhone, that's enough technical expertise to fly a Skydio 2. Obviously, you need a Part 107 license to do it commercially. But the value in making this really easy to fly um, unlocks a ton of value for enterprises. One being JIW. JIW, Japan Infrastructure Waymark, is Japan's leading bridge inspector. They inspect hundreds of bridges a year with their Skydio 2s. And what's amazing about this case study, and the reason that I love to talk about them with customers who are thinking about starting their drone program, is that they were able to reduce the startup cost of ramping up a new pilot from 100 flight hours down to 8. And as a result of that, they were able to save 75% of their costs on every bridge, and now they do every job with their Skydio drones. Here in the US, companies like Accurate Drone Solutions have been saving up to 40% on their flights. And what that means is when you save time, you can do more jobs. And so Sam DeLong at Accurate Drone Solutions is excited because now he's out there doing more jobs and generating more revenue because these autonomous drones are helping him move faster through the work that he is able to book. The Skydio X2 is where things get really exciting, though. This is where you take the brains that you know on your Skydio 2 and you send it to the gym and you come back with a really brawny professional workhorse. That's powered by Skydio autonomy still, but this one is built resilient. That airframe is much more rugged. You've got those antennas that stick up to give you that 6 kilometer wireless range, and you've got 35 minutes of battery life on these big triple props that are quiet, able to cut through that wind and really unobtrusive to the public if you're doing jobs where you can't shut down, a square mile for yourself to do the work. This is the drone that's NDAA compliant. So if you're doing any work for state and local government, for federal government, where your contract is at risk if you are using foreign products that are not approved, well, you're good. The Skydio X2E is on the Blue UAS list. It's fully compliant with the DoD, and it comes in 2 variants, so that whatever kind of job you're doing, you can pick the right one off the shelf. There's a color and thermal variant. That one's great if you're using the infrared, if you need to do search and rescue, if you need to do kind of longer standoff capture, you've got a narrow field of view lens on the visual camera that lets you see things far away. Or there's the color that has a wide angle lens and lets you get right up close so that you can do the same visual inspection and mapping, especially using Skydio 3D scan. I showed right at the beginning here, in the couple minutes before, a quick video to you about Skydio X2. I'm going to save it though, and you can go and find it on YouTube or anywhere on Skydio.com. If you go right to Skydio.com, it's very easy to find this video on the X2 page. Again, very important to a lot of our customers that Skydio X2 be fully compliant. We put a ton of work into making sure that this supply chain was secure, and we manufacture the X2s right at headquarters in the US. So now we're going to talk a little bit about software, and then I'm going to turn things over to Mark to go deep on 3D scan. But the first one is Skydio Autonomy Enterprise Foundation, which is the first of these advanced AI skills that you see. And what AEF, as we call it, Autonomy Enterprise Foundation, AEF, lets you do is operate in the most challenging environments with confidence. So this is what takes you from an expert when you're flying your drone to a superhero. And it lets you fly into these environments where you might have to shrink that obstacle avoidance down on the drone to let that safety bubble allow you into a tough environment. But then you can fly in here, and what you're seeing on the right is an environment where anybody who's ever flown a manual drone has never been in there, because you've got a bunch of metal that's going to confuse the magnetometer or the compass, and you've got a really tight environment with a ton of obstacles that you can't see as the pilot because you're looking out that forward-facing camera. But thank God when you're flying a Skydio, you've got those 6 cameras that let you see, that are watching out for you on the sides, up, down, and behind. AEF is what lets your pilot kind of dodge, duck, dip, dive, and dodge all around the most intense environments. So let's have a quick look at what is in AEF, and then we'll move on to some more of these autonomous skills. All right, we are almost there. I'm going to give a quick preview of 3D Scan as we keep talking through the products, but I'm going to leave a lot for you to learn from Mark. Quickly, the 3D Scan product was made because we looked at all the painful trade-offs that inspectors were making with manual drones. If you're flying by hand, your flights are lengthy and complex, they're risky, it takes a lot of training to get it right. It's really hard to know that you've captured all the imagery you need when you're just taking pictures and not receiving any feedback on what is and isn't captured while you're flying. And if you are using some of the really great photogrammetry software out there, maybe it's Litchi or Drone Deploy or Pix4D, so far you've been limited in large part to these 2D flight patterns. Whether they're horizontal or vertical doesn't really change much that you're bringing a knife to a gunfight if you're trying to scan a 3D scene with a 2D flight pattern. You end up with these really long standoff distances, which is why you need to pay for such expensive cameras on all those drones. Your data is low quality, especially on oblique, right, or vertical surfaces. And your applications end up really limited because of it. There are a lot of areas that you just can't get a good scan of if you're trying to scan with a 2D pattern. And so we made 3D Scan, which is an adaptive scanning solution that lets you get your data capture fully autonomously. We'll show some video on it later, but just know that the workflow is all driven by AI. It's adaptive to any scene, and that lets you get your sub-millimeter resolution so that you can go and do with a third-party photogrammetry software your point clouds and your textured 3D models. But what's really valuable about 3D Scan, like Mark will show you, is that it's a tool for any worker to use. And that's important because when you are scaling your drone fleet, you need to be able to think about not just the pilots you have today, but who are your next 100 or 150 pilots who are going to join your program, right? They may not be full-time pilots. They may be people who just learn how to use the drone as a useful tool, as a pair of flying binoculars. And so we'll talk more about 3D Scan in a little bit when we go deep. But now we've kind of covered all of the hardware, the core autonomy functions, the advanced AI skills. And quickly, we're going to touch on the cloud services that Skydio offers. So far, it's Fleet Manager and Media Sync, but it will come to include streaming and remote operations, that teleoperation that everybody is so excited about getting to in the world of docked drones. The point of Skydio Cloud is to get seamless data flow from the field to your organization. And there are a couple things that we need. Now, what's available now are Fleet Manager and Media Sync. Fleet Manager is seamlessly streaming your metadata, right, where you flew, who flew, so that you can manage your program. Media Sync is streaming your media, your photos, your videos that were taken. And it's especially important, it's doing that seamlessly over Wi-Fi, so you're not worried about your pilots popping out SD cards that may be getting dirty, they get thrown in the back of a truck, everything's bouncing around there. And then they have to go through at the end of the day and figure out, well, shoot, which asset did I photograph with which SD card? I've seen pilots literally taking a piece of paper and taping SD cards to it and just writing with a pencil, what was where. Well, there's no more of that. Now you just upload through Skydio Media Sync into Skydio Cloud. Your photos are all nicely spatially indexed there and split out by flight so that they're really easy to browse. And that gives you as a program manager a ton of accountability as you report upwards, but also you can enforce accountability on your pilots as you manage downwards. Looks like I jumped the gun on myself. Again, that media management, right? Really complex and error prone. And it's replaced with Media Sync on the right, which you can see is absolutely seamless, right? So if you're a program manager and you've got 5 pilots out there flying, 10 pilots out there flying, you're just going to see that media come in at the end of the day, and you're instantly going to be able to browse results, make sure that the data was well captured, and then pass that up your chain of command. That fleet manager, like I said, very focused on that federated management. It's all about who flew, what flew, and when. So you can track your program and you can report upwards. Hey, we did X number of flights this year. We have certain pilots who are flying more than others. Let's go dig in. Let's see what's going on. You cannot manage what you cannot measure. And so having a fleet manager is really important for you as you build out your drone program to be able to understand the trends and dig in when there are issues. Now, what the magic is of this integrated solution is it takes you from the drone to the intelligence to the cloud, right? So this is just one situation that you might find yourself in, but if you're an autonomous inspector, this is a solution that can have a ton of impact for you. You get out there flying with a Skydio X2 color. You've got that wide angle colored camera like we talked about, lets you get right up close and generate good data. How are you going to get up close? You're going to do it with Skydio 3D scan, because like Mark will show you, that's better than using a human pilot. And then what are you going to do with that data? You put it up in Skydio Cloud. You use Skydio Cloud to do your management, do your reporting, deliver work to clients, and your life is easy and simple and fun because you're using Skydio drones. So um, that's the overall picture of the solution. I'm going to hand things over to Mark. Mark, we're actually starting with a video. Did you want me to just play that, or do you have some things to say about 3D scan before we start your deep dive?
You know, I have a lot to say, but let's start with the video.
All right, video it is. So everybody enjoy this as an introduction to Skydio 3D scan.
Alrighty. Thanks, Kim. I mean, just looking at that video, what a reminder. Like, talk about Skydio airspace. Imagine trying to inspect that bridge routinely over time manually. I mean, how many times could you successfully do that before you inevitably had some sort of incident? It's a great example of Skydio airspace right there. So let's talk about the 3D scan workflow and how it is that we're able to inspect such complex assets so simply. So I'm going to step through the workflow so people can kind of understand how 3D scan works and try to demystify it a little bit. So the first part of the workflow, as we saw in that video, is the AI-driven flight planning. So unlike traditional 3D modeling, the drone creates its own flight plan. There's a simple guided workflow. You saw the pilot entering in the parameters, the distance to surface. So that simple guided workflow will help the user set boundaries as well as determine their settings. And then the amazing part is that Skydio will then automatically determine the most efficient flight plan. You're not relying on the pilot or a team member to do that. The drone will autonomously do that. So there's less risk of error or of having to go re-inspect it due to a mistake. The next part is the in-flight monitoring. So while the drone is autonomously scanning, the operator is able to monitor the drone's progress using augmented reality, and they're just responsible to swap batteries as needed. So you can literally watch the drone make progress, as we were seeing with that colored overlay. You're watching the drone complete the scan, giving you that assurance that you're getting the images you need. Then the last part of this simple workflow is the field and back-end assessment. So one thing that I'm really excited about is the Skydio Edge Model Viewer. So using the Edge Model Viewer, you can wirelessly review scan photos in the field that are spatially indexed. So for those not familiar, what a spatially indexed means, It means that you'll look at a preview of the model and you can click on any part in the model and then see a photo from that angle. So it can be very complex when you come home from an inspection. If you have hundreds of photos, you don't know, was that from the south side or from the north or from the bottom or the top? Spatially indexing that photos makes it much simpler to see what photos were taken from where. The last thing that's worth mentioning is that 3D Scan is also completely agnostic with all the photogrammetry solutions that you know and love, like Drone Deploy or Bentley. So you have two options. You can either view your photo in the Edge Model Viewer or process it to make a pretty 3D model. But what this all boils down to, what this field and backend assessment all boils down to, is giving you the confidence to know that after you complete a scan, you have the images you need, you can leave the job site and know that you're not gonna have to go back out there a month later to re-inspect it. So this simple workflow is making complex scenes much easier to inspect. So now let's take a look at the robotic precision for consistent data. So like we've said, like the theme of 3D Scan is that the fundamental goal is to make it easy to enable any team member, not necessarily, you know, a skilled drone pilot, but any team member to capture complex scenes that previously you would have only felt confident to send out a skilled pilot for. So, you know, why is this so important? We want to make a product that is easy to scale, that, you know, large enterprises can adopt confidently, and that's very difficult to do that if your program requires highly skilled operators. It becomes difficult to train and onboard and maintain a staff of highly skilled operators. Of course, you want a solution that's more accessible. So with this new level of simplicity and automation, it makes it possible to roll this out and have folks just adopt this as another tool without days or weeks of mandatory training. Like the example I always like to make is that companies don't have a team, a pickup truck team. People just drive pickup trucks. They don't need a dedicated team that is trained on pickup trucks and has gone through a lengthy onboarding process for pickup trucks. People just know how to drive pickup trucks. We want drones to be like that as well. So let's take a look at the side-by-side images we have here. On the left are manually captured images by a skilled pilot, and on the right are captured by Skydio 3D Scan. So you'll notice three primary differences. The autonomously captured images have more consistent coverage. The overlap is identical from each image. You also have better guarantee of coverage. You're not introducing gaps in your data set by skipping an image or having too much overlap. And then notably and most challenging to recreate is the standardized resolution. So that means that each photo is captured from the same standoff distance from the structure. So even if you're, you know, a skilled pilot, you know, maybe like Guillaume or Mao, you're great at flying, it's really challenging, especially without a rangefinder, to maintain the exact same standoff distance as you orbit a structure. There's no tool in manual drones to really provide you with that insight. So you're just hoping that you're maintaining that same standoff distance, but in the reality is you're not. As you wrap around, the standoff distance changes, and you're not maintaining that standardized resolution. Really the only way to get, you know, the perfect overlap, the perfect standoff distance, adequate coverage is through this robotic precision and through autonomy. It's simply complex, even for the most skilled pilot, like a Guillaume or a Mao, to pull off.
Yeah, and Mark, neither of us was there when it was done, but on the left, that is the most skilled pilot from NTT Docomo, which is a made customer of ours in Japan. They inspect cell towers, and they wanted to have a showdown of their manual pilot versus 3D scan. If you were processing a data set, you know, which one would you rather have, Mark?
That's a leading question. I love the example, and the expert pilots coming out of JIW, the crew from Japan, they are really talented with hundreds of hours. And it is really amazing to see how much better the autonomy is. And that's a great example. Okay, so this is a really interesting slide that I want to let breathe for a second. And I encourage everybody to kind of take a look at these two side-by-side images and really review them. On the left, we have an image from our Skydio 2. On the right, we have an image from a DJI Mavic 2 Pro. The first thing to understand is that what matters is GSD, not necessarily sensor size. So as you fly closer to a subject, your GSD increases. You can see more visible detail in the subject. Since we trust Skydio drones to fly closer than we trust other drones due to that world-class autonomy, we're able to match the same GSD of even more expensive and heavy cameras. So once we can set resolution aside because it's really about GSD. Autonomy unlocks a higher level of GSD. So once we level out the GSDs, we can now look at a side-by-side image and really just compare the image tuning. So you can see on the left, the Skydio image, we're able to see the bolts that are visible. We're able to read text that's visible. We're able to see the rust that's visible. When we look on the right on the DJI photo, those images are washed out or under or overexposed. So this has to do with the fact that the images are tuned for inspection purposes. These are not being tuned for sunset photos or for things like that. These images are tuned for inspection applications. And that's where we're able to get such high resolution, capture so many details in the highlights and the shadows. I mean, anybody that's gone and done inspection realizes the challenge is not in resolution, it's in capturing details and highlights and shadows. If you're taking photos of a roof, part of the roof is in dark shadows, the other part is in highlights. When you come back and review that data, you realize that you've lost some key details due to the lack of high resolution HDR.
And
so
Mark,
that dynamic range, yeah.
What does GSD mean when we say that we're at 1 millimeter GSD?
Sure, GSD refers to grand sampling distances. It's a measurement of like how much distance is in between the center of each pixel next to each other. So essentially, the lower your GSD, the closer you're flying to a subject and the more visible detail that you're capturing. So while it's tempting to look at sensor size, and sensor size equals cost, it's tempting to look at sensor size. What we should really be looking at for inspection is GSD. How much visible detail is in the photo? And that's a factor of sensor size plus proximity to the subject.
Right. And so for those kind of connecting the dots at home, right, when you saw in 3D scan the ability to change the standoff distance, right, how close or far your drone flies from the subject, that changes your GSD. And GSD, the reason we talk about it is that's a much closer proxy for the final resolution of your data outputs than is the resolution of the camera, because a lot more goes in than just the number of megapixels you have. And this is a really important point as you shop and you think about which drones you're going to choose, right? Is it can be tempting to say, well, I see a 20 megapixel camera on that drone and a 12 megapixel camera on this one. Well, I'm going to take the other one, even if it's more expensive. But what Mark and I are here to show you with these comparisons is you really need to think about the output, not the input, right? Because the other input is how close you can fly, right? So you can't just think about the number of megapixels in the camera. You need to think about where you can put that camera. And when you start thinking that way, you start to realize, well, if I can just control GSD by flicking a switch in the app, my final resolution is really easy to manipulate. Well, then I want a lower cost airframe. I want to invest in autonomy, where year over year I can continue to see those improvements in my data sets. Anything else to say on this one, Mark?
Yeah, I mean, it's you touched on something very important there with thinking about the output, not the input. I think that as an industry, we want to like kind of reframe the way we look at this. We've sort of created this vicious cycle with bigger cameras, more expensive sensors that require larger standoff distances. People who are out there flying $40,000 rigs do not get close to subjects because the risk is way too high. Thus, they need a bigger camera to stand farther back, and the vicious cycle continues. When you trust the drone to fly up and close, we saw the video of the drone underneath the bridge, inside the trusses, above the I-beams. When you trust a drone to do that, sensor size becomes a much smaller factor. So yeah, I think what Guillaume said is spot on, and we as an industry want to think about GSD, not just sensor size.
Right, great. And if you're trying to figure this out, feel free to contact us on the website. You'll talk to our sales team, and our solutions engineering team will come and demonstrate this for you and show you some data sets on your own assets that you need inspected. So, so this is something that we highly encourage you to try before you buy, and not just order from some website in China.
And the best thing about going out there with solutions engineers and having them demo is you yourself will set up a 3D scan. You'll realize how easy it is. They'll hand you the controller. You'll walk through the steps, and you'll realize that, oh, wow, this does not require an expert pilot. You literally can just use the screen, click and drag, drop your pillars. You don't necessarily need to know how to navigate around a complex structure. So I would take Guillaume up on that offer. Let us come on by and show you just how simple this is. So we've talked a lot about the ease of use, but now we're going to talk about the value, the cost savings, because that's really what this is all about. So I'll step through this slide that Guillaume has created for us. If you look at the total cost of operating a drone program, of operating an inspection program, we can start to see how we can reduce those costs using Skydio products. So one is we have a 20% reduction simply in reduced worker hours. It's quicker to use a drone than it is to use a climber or a bucket truck. You're simply reducing your cost through less time on site. I talked a lot about the Edge model viewer and the importance of being able to see the data set before you leave the site. That ability helps to reduce the reinspection rate. People that do this for a living realize that reinspection is actually pretty common. And I would even argue that for some newer programs, it represents more than 10%. But the point is that reinspection is part of the game. Using Skydio autonomy to ensure you have appropriate coverage, using the Edge model viewer to ensure that you have what you need before you leave the scene, that can reduce that reinspection rate, which equals real tangible savings. The last one is savings from faster post-processing. So the ability to use 3D scan, take a full data set that will be accepted by an agnostic photogrammetry program like Drone Deploy or Bentley, saves you the time of manually flipping through individual photos, making binders, preparing PDF reports. All that admin work is extremely costly. It's extremely time consuming. Most of the time spent is in post-production. Oh, where's that shot of pole 13? I'm missing the top-down shot. I know I got it. It's here somewhere. We've all been there. Using 3D scan, autonomously capture all the images you need, create a 3D model, inspect off the 3D model using the spatially indexed photos that are already organized for you. That is where the biggest savings comes from in post-production. And then lastly is the reduced crash risk. So even if you have an existing drone program, you're on board, you understand the value, you've fired the bucket trucks and switched over to drones, the reduced crash risk as a UAS program manager is so important. No one wants to be the program manager of a program that has a drone clipper power line and and now the worst case scenario. So having a drone that you trust to fly that can avoid obstacles, that should be the first box that you check. Everything else should drop in after that. But step one is, does my drone see its world? Do I trust it in the hands of a beginner pilot? Will this drone be able to avoid obstacles? Once you check that box, you can start going deeper into your decision path, but you should start with that key fundamental decision because that's what will derail your program. A crash is costly because of hardware, but the cost is much more in the lack of confidence from the internal stakeholders. We've seen programs get downed after bad crashes. That's not good for anybody. So that one is a little bit harder to quantify, but certainly I encourage everybody to think about that as they go through the decision criteria themselves.
Great. Well, that's a great explanation, Mark. Let's have a look at some example 3D scans, and maybe we'll try to finish up by 8:50 here and leave ourselves 10 minutes for a Q&A.
Yeah, here's a fun one captured with the Skydio 2, 450 photos, standoff distance 10 meters, Unreal GSD of 1.25 millimeters. You can see some of the other settings there, captured in 30 minutes on site. I would just pause at that. 30 minutes on site, that's unreal. If you were flying this manually, you'd be there all day and you'd have huge gaps in the data set. So this is a really fun one. Guillaume, correct me if I'm wrong, I think this was actually captured by one of our customers' son. So they're out there using the product. They're getting these phenomenal results themselves. This wasn't done by the Skydio marketing team or anything like that, done by an actual customer, and pretty breathtaking results.
I got to tell you, I got a phone call from this customer right after doing it. There was a lot of profanity in that phone call because he was amazed.
Yeah.
This was the first time, this was the first day that this customer, who happened to be Dean Miller at Sun, we've gone public with this model, had ever used Skydio 3D scan. Got the software, tried it on his house, drove to this job site, and flew it, and was just amazed at watching the flight. We've got more videos of this online if you go to Skydio's YouTube channel. And you can also go browse a couple notes about all these models. Two things. Number one, you can always go browse them online at Skydio.com. Go to resources and find our 3D scan gallery. You can actually go click around them. normally we show GIFs and the big picture at the bottom there would be moving around, which unfortunately we can't do on these webinar platforms. But you can go over to our website and you can browse them and play with them and zoom right in to see all that detail. You don't get the full resolution on the website; it's hard to host, but it's a great experience. And then the second thing I wanted to do is just explain. We've got a couple hundred folks almost on this webinar, and there's a great chance that that thinking in GSD is a new way to think. So just to clarify that 1.25 millimeters means that every pixel on your camera is collecting 1.25 millimeters on the ground, right? So if you think of your camera sensor, it's got a bunch of pixels on it. Each of them is looking out at the world, and depending how far away the thing that they're looking at is, that pixel is going to cover a small distance if it's up close or a big distance as it gets farther away, just like your eyes do, right? And a 1.25 millimeter ground sampling distance means that you're able to detect damage and defaults that are down to a millimeter and a quarter. And I didn't grow up with the metric system, but I know it well enough to know that that's real small. So that's at a 10-meter standoff distance. 3D scan will let you go down to 3 meters, 2 meters, 1 meter in full safety so that you can get that sub-millimeter precision if you're looking for really small defects, maybe cracks in concrete or things like that. Really, really exciting capabilities here. Should we go to the next one, Mark?
Yeah, yeah.
One more note, then I'm done. Then it's the Mark show. Is all of the 3D models here that you're seeing, the data was captured with 3D scan. That means your Skydio drone with the software flew all the photos, and that data was loaded into a processing package. In this case, that was Bentley Context Capture, and that's where you can get your point clouds and you can get your 3D models. What you see when you land the drone is a spatial index of your photos. So it's a very low resolution 3D model. It's not the quality of output that you would show here, but it lets you browse your photos really quickly in 3D in the field. Incredibly valuable capability, but not the full workflow that we're showing here. This does include some work from third-party software as well. Sorry, Mark.
But I think one of the, that's one of the greatest things about 3D scan is that agnostic ability. At the end of the day, you have a batch of JPEGs that are, compatible with multiple processing programs. So if you already have a program in place, then you don't necessarily want to change out the whole stack. You have that flexibility. But yeah, this is an exciting one captured with our research partners, EPRI. Great application for 3D scan, shows the ability to get close to subjects. We're working with them to try to better understand just how close we can get and to create new standards around that use case, which is very important. This is also a great example of the importance of having the edge model viewer. When you get into, power lines, it's a lot of very similar uniform assets. It can be very complicated to remember what was from where. Guillaume shared the horror story about taping SD cards to paper. We want to cut that out, and it's these types of inspections where managing the data is very complicated because it's all very uniform assets. It's easy to lose track of what was from where. Yeah, here's another fun one. Sacramento City incinerator processed with capturing reality. So usually we'll show off drone deployer Bentley. Here's one from capturing reality, just showing off how flexible it is. 20-minute flight time, probably one battery, up around the smokestack. Great use case, very simple application. Done from a 2.1 meter standoff distance. This is another one of those examples of it would be very difficult to do this manually. It would be hard to maintain 2 meters around the entire orbit, even as a skilled pilot. That's the reality, is it's not so simple to do this sort of stuff manually. So great example, great use case.
Right. That maintaining a consistent standoff distance, right? You might get away with it when you show the 3D model like this. You won't have some parts that are fuzzy and some that are perfect. But when you have a piece of damage that you need to zoom in on, you need to look at the actual photos. You want them all to be from the same distance so that you've got consistency and you can draw conclusions and be useful when you get out there for the repair.
All right, this one is particularly near and dear to me. I actually scanned this with my dad on a vacation day. My dad is not a drone person necessarily, but he was able to grab the iPad and use his fingers to drop the pillars around and able to capture this old silo located in upstate New York. This is a great example of the importance of 3D scan. You can see the facade of the silo is severely degraded. It actually creates risk when it's like a really windy day. You know, you can have pieces that are falling off of it. The feeder pipe is totally rusted out. So we were able to knock out this inspection 40 minutes on site at a 10-meter standoff distance. Around 1,000 photos. It's a very tall silo. But you know, the part that I'd love to share is just that this was done by a beginner pilot. This was not even done by a pilot. This was done by my dad, who was able to capture this great photo set, and just a great example of the ease of use of Skydio 3D Scan.
Yeah, next you'll have to show him how to use his VCR.
Yeah. Here's another great example of a use case that we see very much trending, which is accident and incident reconstruction. I mean, look, what I would want to talk about here is 13 minutes. Whenever there is an accident, the risk of a secondary accident goes up exponentially. You know, there's a crash, the sirens come out, people are rubbernecking, and the risk of secondary crashes becomes very common. Being able to thoroughly document the scene in 13 minutes helps you clear the scene quicker, reduce the risk of a secondary accident. So this is a great example of using 3D scan for accident or incident reconstruction. Here we've set up a mock crime scene. You know, since Skydio has the ability to capture this at such a low GSD, we also are able to take highly accurate measurements off of the model. The lower the GSD, the more accurate your relative measurements are. So it becomes a very, a very powerful tool for crime scene documentation.
We like to point out that no crash test dummies were injured in the making of this 3D model. A couple of closing thoughts before we bring Mao onto the scene to ask some of the most poignant questions from the chat. Number one is look at all of these flight times, right? The longest flight was 42 minutes, I believe. And you're always trading off flight time for resolution, right? Higher, you fly up close, it's gonna take you a little longer, but you'll get better data. You fly from far away, it's a nice quick scan, save you a bunch of time. That's gonna depend on what you need, right? So when you work with Skydio Solutions Engineering or even the sales team, we've seen enough of this that we can give you some really good advice on how to generate the resolution that you need to meet your requirements and deliver the right data. And then advise on how much time that's going to take. Now, I've talked to pilots who say, oh, I don't want to use 3D scan because it's going to take too long. I just need a few quick photos. And what I challenge them is there's no way that you're capturing that data in less than 13 minutes. And when you go out and fly it with them, they aren't. But the difference is with 3D scan, they're bored. They're like the Maytag repairman sitting there watching the drone do all the work. But that is the future. These drones are better than humans, like we saw earlier, at generating really great data sets. And so we're really excited about, for the expert pilots who love flying, right? This is a new motion, right? But we're really excited about, the next 10, 100, 1,000, 10,000 pilots that come and join our beautiful little industry here and what they're able to do with 3D scan. So with that, let's take a few questions. Now, if you're available.
Yeah. Hi, everyone. Hi, Guillaume. Hi, Mark. Great presentation as always. So yeah, we have a bunch of questions here. Let's see how much we can cover. The first one was very early on in the presentation. I think it's super relevant given what we just did with the Skydio 3D scan product. Question said, did I read that we can do 2D scans in addition to 3D scans with the product? So love for you to answer, especially given our most recent software release.
Yeah, the answer is yes. You can set up when you set up your 3D scan, it's just a setting in there, whether you want to fly in 2D or 3D. You're going to want to use 3D anytime that you've got vertical surfaces down below in the scanning area. And 2D, if all you need is maybe an orthomosaic. Beautiful thing about that 2D scanning is the ability to fly lower and not have to worry about obstacles being up in that area, right? You manual pilots are probably all thinking, well, what's my MOCA? What's my minimum obstacle clearance altitude, right? And trying to stay up above, maybe a tower crane on a job site or a sign, right? I know somebody who got their Phantom 4 stuck in the golden arches of a McDonald's doing one of these 2D capture flights, and you just don't have to worry about that with a Skydio. Anywhere you need it, whatever altitude you need to get the right GSD, go and do your scan.
Yeah, I think to that point, I think the natural inclination is to fly much higher than you need to for safety reasons, right? Safety first. So thus you're capturing these data sets, especially in 2D scan from 150 feet up, when with the Skydio, you're confident to send it in at 30 feet, producing much better results. So it has 2D scan, but unlike using 2D scan on other drones, you can actually use it at an appropriate altitude to get good results.
Thank you. Thank you for those answers. So now the next question I have here is, I think it's relevant, and sometimes, you know, we're focused very much on 3D scan, but we also sometimes need to level set on the way Skydio works, right? Like a lot of people are still new to Skydio, and some of these concepts around when we talk about, you know, not relying on a magnetometer are still a little bit foreign to some of our audience members. So this question is actually, I think, very, very interesting for us to address and really explain what Skydio is about. Like the question was, what is the name of the hardware component in the Skydio 2 that replaces the magnetometer? So I think that's very, very obviously very interesting for us to answer. What is that, the name that replaces the magnetometer? So please take a stab at it.
Yeah, well, I can take a shot and then I'll pass to you, Mark. It's the Skydio Visual Navigator, is what is replacing your standard magnetometer and GPS flight. Skydio 2 still carries a GPS unit, but is not dependent on it. The X2 carries both a GPS unit and a magnetometer, but as long as there's daylight, not dependent on it. And what that Skydio Visual Navigator is a combination of 6 cameras. They're all 4K color sensors that are fisheye lenses, and they're always taking in the surroundings. And then we carry an NVIDIA Tegra TX2, which is orders of magnitude more powerful of a chip or an intelligence unit on board the drone than you'll see on anything else in the industry. And that's the piece of compute that is running your 9 different neural networks as it flies, managing your 3D scan and kind of building a 3D model of the world that the drone is constantly navigating itself through. And so, you know, this is a much more direct way for the drone to do what we call state estimation, right? But understanding where it is in space, because it just looks around the way that a human does, right? It's not trying to talk to a satellite in space or figure out where the North Pole is to determine where it's going to fly next. So that Skydio Visual Navigator is where all the magic comes from.
Yeah, I would just to add to that, I mean, I think that to bring it home back to 3D scan, that's why it's such a good platform for 3D scan, because we're not just using a GPS to take random photos every 10 feet blindly. We see the surface, we scan the surface, we capture the photos we need to cover the surface, as opposed to just like, imagine putting on a blindfold and firing off a camera. That's kind of the comparison.
Yeah, and I would just emphasize the shift in mindset that we have here, right? Where like the question was, what is the name of the hardware component that replaces this, right? Like, and it's not hardware, right? Like we're all about creating magic through software, right? So that is really what people need to take away when they think of Skydio, is that a lot of what we're doing is based on pretty amazing software that we build into this product. So the next question that I thought also was related to this question is around 3D scan is, are the images still geotagged by Skydio, or does the visual index replace the geotags? Can you answer that?
Yeah, that's a quick one. The answer is yes. They're geotagged, and that's why we're able to throw these images into Bentley, into Capturing Reality, into Drone Deploy, and work with your existing provider of photogrammetry software to generate point clouds and textured meshes out of your 3D scan data. Yes.
And one very last question, because we're at the top of the hour, but I think we should cover this one, is somebody said like that they were interested in cloud, but say we're not allowed to use cloud processing in some of our plants. Can we disable that feature and just use the SD cards?
Sure. Yep. Yeah. That's always going to be an option for you.
Yeah, so cloud is really just a fantastic but yet optional add-on service to our drones. So if for whatever reason it doesn't work for you, you can continue to operate with your SD cards from the drone directly.
All right. Well, Danielle's back. Looks like the 3 of us are getting the yank, but thank you everybody for coming out with us this morning. It's been a lot of fun. This is this is what Mark and I talk about at lunch. So, so we're excited to be able to talk about it with all of you, and of course to do it with our friends at DivCon. So thanks so much for being here this morning, and safe flying out there.
Thank you,
Thanks, everyone.
Guillaume. Thank you, Guillaume, Mark, and Mao for another great and informative webinar. Before we sign off, we have a few remaining bits of business. Stay tuned for a follow-up email on accessing the on-demand version of today's program. All those videos that you saw today will be embedded in those. So if you did have issues with seeing the videos, please stay tuned for the on-demand version. We're always eager to receive your feedback, so please complete the short survey that will appear when you log out. And thank you all for taking the time to attend this webinar. Have a great rest of your day and safe flying.